Hey everyone, Mrs. Demeyers here, and we are going to go over lesson 3.3. So make sure you dig out your Moon Jelly notebook, and we're going to go over this. But first things first, in your lesson plans for today, we put something in there about saying one word that sums up how you're feeling today. And so I want to take a moment and share what mine is. You can see my little guy right here. My word is happy. And what I did with my word is I wrote a haiku. A haiku is a style of Japanese poetry where there's 5 syllables in the first line, 7 in the second, and then 5 in the third. And so my happy haiku says, happy is my word. Here comes the sun this week. Yay. Love to be outside. So I love the sun. I love the heat. I love to work in my garden. And so that just makes me happy. And so that is my word today. So are you ready? Let's go ahead and get going with lesson 3.3. All right, first let's look at our learning intentions. All students will look at the glacier seafood web and make predictions about populations other than the zooplankton or sea turtles that may have caused the jelly populations to increase. In addition, all students will practice using important unit vocabulary and review ideas about indirect effects in ecosystems. Our success criteria. I can identify possible indirect effects in an ecosystem and explain the changes I observe from the indirect effects. All right, first things first, let's take a look at page 85. You're going to go ahead, read the header first, underline that unit question and read it aloud, underline the chapter question, read over the key concepts 2 times, read over the list of vocabulary words. Now pick 2 of them and write down the definitions in the space below, just for review. And if you need some help, you can look in the glossary and it's in the back on page 129. So go ahead, pause this video and complete the instructions for page 85. Now that you wrote over everything and listed your 2 vocabulary words, I'm going to show you mine. I chose indirect effect and sample, and I got those definitions right out of the back of the book. So if you skipped ahead with the video and didn't do that, why don't you pause it now? Go ahead and pick 2 words and write 2 of the definitions down. All right, let's look at our warm-up on page 86. Here we have a picture of the glacier seafood web. This should look familiar. We've been using it for this whole chapter. And the question says, you've already discussed how the zooplankton and the sea turtle populations might have caused the size of the moon jelly population to increase. Which other populations do you think could have caused the size of the moon jelly population to increase? It gives you the 5 options there of the walleye pollock, the algae, the orca, the sea urchin, the kelp. So check off the boxes as far as which ones you think could have caused the moon jelly population to increase, or just change, or decrease even, and explain your thinking. So down below in the box here, write your reason why. Pause this video and explain your thinking. And if you needed some sentence starters, they're right down here. So now you've paused the video and written down your explanation. Let's go over what I thought. I wrote that the walleye pollock, the algae, so our fish sticks, the algae, and the orcas, so fish sticks, algae, orcas, that they are all connected on the food web so that they can affect the jelly population. However, the sea urchin, this guy here, and the kelp, this guy here, are not connected with the jellies on the food web so that they cannot affect the size of the jelly population. So if you have something along those lines, give yourself a high five and go like that. Or if not, go ahead and write that in now. Let's take a look at our chapter question. How could a population besides the zooplankton or the sea turtles have caused the moon jelly population to increase? So what we're looking at here is indirect effects. Now, an example of an indirect effect, and I think I've mentioned this before, that if you binge watch Netflix, TikTok, or Disney Plus all night long before a big test, this is what you may end up with. Now, did Netflix, Disney Plus, and TikTok give you the F? No, they didn't give you the F, but maybe they caused you to not sleep, or they caused you to not study or forget to eat breakfast, and because of that, you did poorly on the test. So that would be an example of an indirect effect. So we're going to look at more indirect effects in the simulation. So populations that are not directly connected on a food web, they can still affect one another. So we're going to complete each mission and show how that is possible. So get ready, put on your detective hat. I've got mine right here. And go ahead and turn to page 87 in your Moon Jelly notebook. Pause the video and go ahead and read over what we're going to do. And I'm going to demonstrate all of this with you on the simulation. And if you have access to the simulation, which you may or may not, depending on your situation, feel free to run the simulation with me. You can always put the video, like put one video screen here, put the simulation screen here. We can do it together, or you can watch me do it and then go ahead and do it on your own. But for right now, pause the video and read over page 87. So you've read it over page 87, off to the simulation we go. Now, I can't show you exactly how to log into your simulation because I don't have access to Clover. But what I can show you is where to go once you get into Amplified Science. So what you need to do is you need to get to Chapter 3, Lesson 3.3. And remember here, you can push the Amplified Science button, and this is kind of like your home button. It takes you home. So I'm going to do that. I'm going to scroll to where it says Population and Resources, because that's our moon jellies. I'm going to click that. Then I'm going to go to Chapter 3, which is where we're at, and I'm going to click Lesson 3.3. Okay. From here, I'm going to go to Section 2, which is where we're at. And then right here, Mission 1, it says Open Population Resources and Sims. So I'm going to click that, and our population and resource sim will load. I'm not using an iPad. My simulation has loaded, so now I'm going to click where it says 6 populations. I'm going to go ahead and pause it. Now, remember, if you look at Mission 1, it says find a way to increase the size of the claw cat population without changing the size of the scale beak population. Okay, and in number 3, it says to record our idea below. So are we going to increase or decrease, and then which population? The green leaf, the wee bug, or the furbill? So what I'm going to do is I'm going to do each of them for you. So the first one I'm going to do is I'm going to go ahead and I'm going to let my time run for 20 units of time. And then I'm also going to speed this up. I'll pause it, and let's do the first thing. Let's increase the green leaf. So I'm going to go here and just crank these up. Okay, and then I'm going to lock it. And now we're going to let the time run for 200 time units. And what we're looking for is we're trying to get this claw cat population. Scoop this over. We're trying to get this population increased. We've let our simulation run for 200 time units. Our goal is to increase our claw cat population. So let's take a look at our analyze screen and see if that happened. Okay, if we go all the way back over here to 20, where we started, it looks like our claw cats were at 4. This is where we increased the green leaves. And our claw cats ended at 3, so that definitely did not work. Okay, so let's reset and try to decrease the green leaves and see what happens. So once again, I'm going to let my time first run for 20 seconds. That kind of establishes a baseline. And then we're going to decrease our green leaves down. I'll leave 1 in there. Let's leave 5. I need something to eat. Lock it, and let's go ahead and run it. We've run the simulation for 200 time units. Now let's look at the analyze screen and see if we were able to increase our claw cats. So if I wind this all the way back to 20 seconds, you can see this is where we decreased the green leaves. We had 4 claw cats. Yeah, 4 claw cats. And then if we run our analyze, we end up with 3 claw cats. Interesting here how the wee bugs started out high and then they went low and they ended up going back up. That's interesting there, but that's not what we were looking to do. We were looking to try to increase the claw cats. So that didn't work. Let's go back and reset it. We're going to reset. We're going to run it for 20 seconds. Speed it up for 20 units of time. Okay, now let's try the next thing. Let's increase the wee bugs and see what happens. Let's go up here. We're going to lock it. Okay, and then we're going to run it for 20 units. We ran our simulation for 200 units of time. And so here's the numbers we ended up with. Looks like we still got those 4 claw cats there. Let's look at our analyze screen and see what happened there. So I'm going to go back up here. I'm going to drag my bar over. Okay, there's where we made the change. So we had 4 claw cats here. Here's where our wee bugs went all the way up. And let's see, our green leaves went down. And it looks like we have 4 here. So yep, our population stayed the same. So that one didn't work. Well, it worked, it just wasn't what the result that we were looking for. All right, so let's reset our simulation. Let's go ahead and run our 20 units of time. Okay, and then we're gonna pause it. Now we're gonna go ahead and we're gonna decrease the wee bugs. We'll leave 5 again, like we did with the green leaves, to keep it consistent. Log. Okay, and let's run it for 20 units of time and see what happens. We're starting with 4. Let's see what happens after 200 units of time. I think I keep saying 20, I mean 200. We ran our simulation for 200 units of time, and it looks like we started with 4, we ended up with 4. We have lots of green leaves now, and we've only got our 5 little wee bugs, and we've lost some furbills. Let's look at the analyze screen and see what's going on. Whoa. Okay, let's drag this back. So right here at 20 units of time where we decreased our wee bugs down, immediately after that, our green leaf shot up, but it doesn't seem to have had an effect on our clock hats. We started with 4 and we ended with 4. Okay, so let's reset and let's try another variable. So I've reset the simulator. We're gonna let it run for 20 units of time. Go ahead and pause it. Now this time we're going to increase our furbills. So I'm gonna increase them all the way to the max. I'm gonna lock it, and then I'm gonna let it run till the 200 units of time here, and then we'll see what happens. So we started with 3 clock hats. Let's see where we end up with. The simulation has completed, running up to 200 units of time. Take a look at this. We started with 3 clock hats, and this time we have 7. So let's look at our analyze. So we're on our analyze screen here. Let's go back in time. We'll go back to the 20 units of time. Here's where we increase the furbills up. Now as we go along, we can see the clock hat population goes from 3, there it's at 4, 5, 6, 7. So if we look back on our run screen, again, keep in mind this is where the energy storage molecules are transferring. So the green leaves are transferring here to the wee bugs. The wee bugs are transferring energy to the stingwings and the furbills are transferring energy to the scale beaks, and the scale beaks are transferring energy to the clock hats. So by providing more energy to the furbills, the scale beaks had more energy, and so there was more burst for the scale beaks, there was more energy storage molecules available for the clock hats, and therefore that's how we were able to increase the clock hats. So go ahead, answer the question on page 87, describing the change that you made that led to the increase in the clock hat population, and explain why it led to an increase. So how did it happen? And I basically just said it. So if you're not sure, pause the video and rewind, and then we're going to head back over to the PowerPoint. So we're back here on page 87, and make sure you answer this question at the bottom here. And remember, the change we made is we increased our furbills population. If you need a sentence starter, we can say that by increasing the furbill population, the clock hat population increased because. So go ahead, fill in the blank on that. Pause the video if you need to. So what I said is that increasing the furbills led to an increase in the clock hats because a larger furbill population can supply more energy storage molecules to their consumer population, the scale beaks. Since the scale beaks get more energy storage molecules, they can reproduce more, which leads to an increase in scale beak births. So now there's more births in the scale beak population. The population size of the scale beaks has increased. As a result, the scale beak population can supply more energy storage molecules to their consumer population, the clock hats. Since the clock hats can get more energy storage molecules, they can reproduce more, which leads to an increase in clock hat births. Since there are now more births than deaths in the clock hat population, the clock hat population size increased. If you don't have all that in there, that's okay. But do you have the idea that the furbills provided more energy to the scale beaks, who were able to provide more energy to the clock hats, which led to an increase in the clock hat population? That's basically what's going on. So if you have that idea, you're good to go. All right, so we are going to go over to page 88 for our next mission. So go ahead, take a moment, read over this page, and either in your workbook or up on the screen, and then let's head over to the simulation. We're back at our simulator on Amplify, and now I'm going to go ahead and let the simulation run, again, for 20 units of time, just to get our baseline started. Okay, and now let's look. Remember, with mission 2, we are trying to find a way to decrease the size of the green leaf population without changing the size of the wee bug population. So we're trying to decrease the green leaves without changing the wee bugs population. So look at number 3, and it says to record your idea below. And that, do you think that either increasing or decreasing one of the populations, either the stingwing, the furbill, or the scalebeak population, will cause the green leaf population to decrease in size? So we're either going to increase or decrease this population, or the scalebeak population. So go ahead, circle your answers now. What I'm going to do is I'm going to do just like I did with the last simulation, and I'm going to run each of them until we find the result that we're looking for. So the first thing I'm going to do is increase the stingwing population. So let's increase our stingwings. Come on, there we go. And let's lock it. And then we're going to let the simulation run up to 20 units of time. And the green leaves, we're starting at about 120. Let's see what we end up with at the end of it. So I've let the simulation run for 200 time units. And if we take a look at our green leaves here, they have definitely not decreased. Let's look at our analyze screen, just for fun. We're going to run this back to 20 units of time here. And our green leaves were at about 120. And if we just slowly go through this, we can see they're increasing. They decrease a little bit, and then they increase. But overall, we have increased them. So let's go ahead and reset, because that is not the result that we're looking for. I'm going to go ahead and run this for 20 units of time just to get our baseline measurement. Pause. And then let's go ahead and decrease the stingwings. We'll go to 5. That's the number we used before. We're going to lock it. Now we're starting this time with 125 green leaves. Let's see how many we end up with after we've run it for 200 units of time. Our simulation has run for 200 units of time. Take a look. We're down to 58 green leaves. So if we look at our analyze screen, let's go here to our 20 units of time. Here we go. This is where we decreased our stingwings down all the way down to 5 here. We had 127 green leaves. Then if we look over time, that green line, that population is decreasing. Now as that population decreases, as the green leaves decrease, the wee bugs actually increased. There you go. Okay, let's go ahead and see what happens when we increase our furbills, just for fun. So I'm going to reset my simulation. I'm going to go ahead and let it run for that 20-second count off, or 20 units of time count off. I'm going to pause this. Let's increase the furbills and see what that does. Where are they? There they are. Let's see if this causes the green leaf population to decrease. So we're starting at about 150. Let's see where we end up after 200 units of time. So it's been 200 units of time, and our green leaves have not decreased. So let's look at our analyze screen. Let's go back to where we started, which at 20 units of time. This is where we increased our furbills up. Our green leaves were at 142. And then you can kind of see how they've gone up and they go down. But overall, at the end, we end up with 155. So that is not a decrease in the population. Okay, let's reset and let's see what happens if we decrease that furbill population. Oops. So we're going to go ahead and let it run off for that 20 seconds or 20 units of time. I keep saying seconds because that's normally how we measure time. But this is definitely not 20 seconds. So let's take our furbills down. We're going to use that 5. We're going to leave 5 of them out just because that's what we do. And then we started out with about 120 green leaves. And let's see where we end up after 200 units of time. Take a look. Our simulation has run for 200 units of time. And look at our green leaf population. That it has also decreased with a decrease in the furbills. So let's look at our analyze screen and see what happened. Let's go back to our 20 unit at a time measurement. This is where we decreased our full furbills down. And we can see when we decrease our furbills, here's our green leaves, they decrease, but look what increases. That wee bug population increases. And then as the simulation goes on, the green leaves are still down and the wee bugs are still higher. So there's another way to get the green leaf population to decrease, and that was by decreasing our furbill population. Okay, let's see what happens when we play with the numbers in the scalebeak population. So again, we're going to let it reset. We're going to let it run to 20 units of time. And then let's see what happens when we increase our scale beak. So I'm going to go ahead and increase this up. I'm going to lock it down. Let's see what happens to our green leaf. So we're starting out at 140. Let's see what happens after 200 units of time. Our simulation has run 200 units of time. So now take a look. Our green leaf population is now at 114. So if we go to our analyze screen, we can see, go back to 20 here. We started out with about 140 green leaves. And as the simulation went on, we ended up with 114. So that's a decrease in our green leaf population. So we can say that an increase in the scale beak population is a decrease in the green leaf population. Well, let's go ahead and reset and try one more simulation. So we're going to go ahead and do our usual, let it run for 20 units a time. Oops. And then let's decrease that scale beak population. I'm going to take it down to 2 just to create a more dramatic effect. And then we're starting out with 129 green leaves. Let's see how many we end up with after 200 units of time. Whoa, we've run our simulation now for 200 units of time. Take a look at this green leaf population, 277. That is not a decrease. So if we look at our analyze screen, wow, that line is high. Let's go back to 20 units of time about here. We can see our green leaves. And then we're going to scroll all the way to the right, and then they just start climbing. Ooh, at one point it peaked out. All right, so we are done with our simulation. So let's head on back over to our PowerPoint. So we're back here at our PowerPoint on page 87. Take a moment, if you haven't yet, pause this video and describe the change that we made that led to a decrease in the size of the green leaf population, and explain why that change occurred. If you need a sentence starter, you can use the one on the screen. Let's go ahead and pause the video and complete that now. So for my example, I decided to talk about the fir bills. And I said that decreasing the fir bills led to a decrease in the green leaves because a smaller fir bill population needs fewer energy storage molecules, so they'll eat fewer wee bugs. And then a decrease in the wee bug deaths means there's more births than deaths in the wee bug population, so the wee bug population size increased. A larger wee bug population needs more energy storage molecules, so they'll eat more green leaves. So there's more green leaf deaths, so an increase in green leaf deaths means there's fewer bursts than deaths in the green leaf population. So the green leaf population size decreased. So basically, again, if you don't have all that, that's fine. But your ideas need to be how changing one population led to a change in the other and the reason why. So what we're looking at, our key concept here, is that the size of a population can be affected by any population that is connected to it in a food web, even if they're not directly connected. So the algae can affect the moon jellies, the wall-eyed polyps can affect the population size of the moon jellies, and the orcas can affect the population size of the moon jellies. Great job on completing the simulation part of the lesson. Let's move on to one last thing, and we're going to read over the ant and the acacia. So turn over to page 90 in your workbook, and I want you to take a quick moment to read over the questions on page 90. And then after you're done with that, turn to page F1 in your Moon Jelly booklet and read and annotate the article. Now, a quick note on the annotations. Remember, the goal of annotations is we're making deeper connections to what we're reading. So we want to know, what questions do you have? What words are new and confusing? What do you wonder about when you read the text? Does this remind you of anything? Is there something you have done in the past, either at school or at home, that relates to this reading? Okay, so go ahead and turn to page F1 in your Moon Jelly booklet. Pause this video and annotate it, and then when you're done, unpause the video, and we're going to go ahead and answer those questions and look over the annotations, okay? So pause the video. So I'm going to take a moment for you and show you how I annotated my article. Now, the first thing I did is I took a look at the picture, and I thought, well, where do acacia ants live? In what part of the world? Oops. And then I also wanted to know, what does an acacia tree look like? I've never heard of an acacia tree before, so I wondered, I see this is a close-up picture, but I wondered, what does this picture look like? So let's take a look about how I annotated the article. I went ahead and highlighted 2 words that I maybe knew the definitions of, predation and mutualism, but they're not something I use in my everyday language, so those stood out as important to me. I also took a moment to underline this sentence. However, not all relationships in ecosystem are like this. In some cases, 2 species interact with ways that are good for both species. And I thought about an interaction between a clownfish and a sea anemone. See, usually fish can't swim with sea anemones because they sting them, but clownfish have the ability to swim in these sea anemones, and it made me think of Finding Nemo. So that was a connection that I made. I wanted to make sure that I underlined my definition of mutualism. So mutualism provides both species something they need. And I found out an answer to one of my questions from before. So remember I asked, where do acacia ants live? In what part of the world? Well, I found out that the bullhorn acacia trees, they're thorny trees that grow in Central America. So what the reading was able to actually answer one of my questions. On the next page, I highlighted that the ants shelter inside the big hollow thorns of the acacia tree. And this was shocking to me because I never realized that ants could live in trees. I always thought ants lived in the ground. And so I drew a little picture of an ant in a thorn saying, I'm home, to help me remember that ants live in the horns of the acacia tree. I also highlighted that the ants release a bad smelling chemical to ward off predators of the acacia tree. And I wondered, is this like a skunk? And can humans smell it? And I also drew a little picture of the ants protecting the tree and his little backside emanating like a skunk would and saying stinky ant. I underlined the statement that mutualism is helpful to both species, which means both species would be harmed if the population of one species decreased. So I said that if the acacia tree population goes down, then my ant population is going to go down. And then just as if the acacia ants would be harmed if the bullhorn acacia trees disappeared, the trees would be harmed if the ants disappeared. So if my ant population goes down, then my tree population is going to go down. And then I underlined that acacias wouldn't be able to rely on the protection the ants provide. And I wanted to know what animals actually eat the leaves of the acacia tree. So are they big animals? Are they small animals? And then I put a connection here that the ants aren't always beneficial to plants. See, in my garden, I have kale that gets aphids sometimes, and the ants will do what my dad always called farming the kale. So basically what happens is that the aphids produce a substance that's sugary for the ants, so the ants get that, and they protect the aphid. But the problem is the aphid's not good for my kale, so it kills my kale. So that would not be an example of a mutual relationship, at least not for the kale and the aphids. All right, so those are just some annotations I made. Basically our goal is making connections, underlining stuff we don't know, underlining important things, and then just trying to relate what we're reading to our personal life. Now we're back to page 90. And we need to take a moment to answer these questions. Go ahead and pause the video and answer the 3 questions. So the first question, the ant and the acacia have a mutualistic relationship. What does this mean? I said the ants need the acacia and the acacia needs the ants. Our next question, what do the acacia ants get from the bullhorn acacia tree? The ants get food, water, and shelter. The third question, what do the bullhorn acacia trees get from the acacia ants? The trees get protection from the animals that would try to eat them. And that is it. Great job. I will see you next time for lesson 3.4. Keep up the great work.